Hello friends, this is Dr. Anand Pai coming back with problems in 1D motion. Today we have picked a problem from NCERT textbook. The question goes something like this. Okay, this is a bit tougher question. Okay, a ball is dropped from a height of 90 meter on a floor. At each collision with the floor, the ball loses 1/10 of its speed. Plot the speed time graph of its motion between t is equal to 0 seconds to t is equal to 12 seconds. Let us understand this problem. So we have a ball which is dropped, say, from a height of 90 meter onto the ground, right? So initially when it is dropped, starting velocity, I will call it as u1. This is 0 meters per second. And when it drops over here, it has a velocity, say v1. What is that velocity is not known. But whatever be the velocity, once it comes back like this upwards, then it will have another velocity. We will call it u1 because that is the next starting velocity I will call. I will say u1. Sorry, u1 is here, then next we will call it u2. This u2 will be 0.9 of v1. That is 10% it loses, means 0.1. If it is 1, 0.1 is lost. So once it bounces back, because some energy is absorbed by the ground, the velocity with which it hits the ground, it is not the same with which it will come out, right? And because of that, it won't go to the height 90 meter again. Initially it was at 90 meter, right? So it will not go back to this 90 meter, somewhere below. Now the question what is asked is to plot the velocity versus time graph. That is on the y-axis velocity, x-axis time. Let us look at it. Okay. So first of all, let us see what are the unknowns here and continuously find it out. The equations of motion, as we know, we can write it. We have the equations as v is equal to u plus at, then s is equal to ut plus half at square, and we have v square is equal to u square plus 2as. Now initially what is unknown is v1, we will find out. Okay, so to find out v1, you know what is given. Given are, we have u1 which is given, okay, which is given as 0 meters per second. The height is given as s 90 meter, it is known to us. Acceleration we will generally take it as g, which is 9.8 meters per second. In NCERT we generally take 9.8. And sometimes in JEE questions they give it as 10. Whatever is given, that you can assume. Okay, 9.8 would be g. But what would be the direction? Now when we start with any equations, directions are important, is it not? Because these are vector quantities. We will take the direction downwards as positive. Okay, we will take direction downwards as positive. If we take that, now if you see the first one, t is unknown as well as v is unknown. We cannot use this, right? This is not known. The second one also, time is not known here, and acceleration is known, s is known, but here what happens, what we want now is v1, and v1 is not there here, right? So we will use this equation. The equation we will use is v square is equal to, or v1 square is equal to u1 square plus 2as. This implies v1 is equal to u1 is 0 square plus we have 2 into 9.8 into 90 meters, right? So my v1 would be square root of 1764, which is 2 into 9.8 into 90. That comes out to be 42 meters per second. Now that is the velocity when it reaches the ground. Now next point is it reaches the ground at 42 meters per second, that is known. Now when we have to plot velocity versus time graph. In case I need to plot the velocity versus time graph. Velocity is known, but time is not known, is it not? So let us calculate the time. So to calculate the time, we will use the first equation. We will say V1 is equal to U1 plus A into T1. Let me call it T1. Okay. So here, velocity, we need T1. So T1 would be equal to V1 minus U1 divided by A, which would be equal to V1 is 42 minus U1, which is 0, divided by 9.8, and we will get the answer as 4.28571. We can take any number of, it continues further, but we have taken only till here, or we will take further down. We will say time T1 is equal to 4.2857. I have rounded it off, so I have this one is less than 5, so it goes off, so it's an approximation. So we get a T1 here, we get velocity. Initially the time was 0, which was when it was at the highest point, and the velocity continuously increases, right? Increase to what point? Increases to 42 meters per second. After what time? Time is 4.2857 seconds. So many meters per second, is it not? This in meters per second, and this one would be in seconds, right? But now the question is, we have to join the point origin here with this point over here. Okay, say point 1 here. So now, how should we join this? Whether we should join it with a circle, we can join it like this, we can join it this way, we can join it in a straight line. But what is the right way of solving? Or what is the right way of joining these two lines? The right way of joining this line would be understood when we get the relationship between velocity and time, functional relationship. And that is given by this equation, right? V is equal to some constant plus some acceleration into time. You see, this is a variable, this is a variable, and it is linear function. This is similar to having y is equal to say constant plus mx. M is the slope, which is acceleration, and x is linear. So it is similar to a straight line. So we have to join this using a straight line. That is understood now. Now next point, how will we go? See, just after it hits, it goes up, is it not? When it goes up, it loses its velocity. So when it goes here, it loses its velocity. How much does it lose? It loses 0.9. So we have this loss. Let us take the loss again. So what we have got till here, we have seen that the velocity versus time graph, you will have 42, and then here you have 4.2857, right? And then it goes over here and it joins using a straight line, right? It's a straight line joining there, okay? So you join it using a straight line, right? Okay, so this is the initial line, but after it reaches here, it loses within a fraction of second, it loses the velocity. How much does it lose? So we will say U2 is equal to 0.9. Why did we use 0.9? 10% it loses. So it is 0.9 into V1. What is V1? 42, right? So this would be 0.9 into 42, which would be 37.8 meters per second, right? So here it would lose a bit of velocity, okay? So it loses velocity, and this is nothing but 37.8. Now with this 37.8, now what is happening? There is a ball here. It has dropped down from 90 meter, right? It has dropped down by 90 meters, and it has dropped down at 42 meters per second here, and then it is going up. With what velocity? Say u2, right? So velocity is u2. u2 is what? 0.9 of v1, which was equal to 37.8, right? So 37.8 meters per second, it is going to go up, right? So now the question is how high it will go. What is the place it will go from here? To what height it will go? We need to calculate. So to calculate this, which equations can we use to find out how high it is going? So three equations are there. We have V is equal to U plus AT. We have S is equal to UT plus half AT square. And then we have V square is equal to U square plus 2AS, which would be easier. Now here time is not known, u is known, acceleration is known, so we cannot find. What we need to find out is to what height it goes or what is the time till which it goes. That's also fine. Okay, so let us use this only, right? So we'll use the first equation. We know, so when it reaches over here, we do not know the height we will see it later. We will see what is the time, because what is required is time versus velocity, right? So by what time it will reach the top position? For that we need to find out V2 is equal to U2 plus A into T2, right? And we need to find out this T2, okay? So and this T2 is equal to V2 minus U2 divided by A. What is V2? V2 is 0 because when it reaches the top, the velocity will be 0. Minus U is 37.8 divided by, what is the acceleration? Acceleration would be 9.8, right? Now, what is the direction of acceleration? U2, when you see here, we have taken the downward direction as positive, is it not? So, my upward direction should be negative, the velocity upward should be negative. So, what should happen here? This should be minus 37.8. The directions are very important, students, otherwise we will miss out on that. Okay, so velocity downwards is positive, upwards is negative, and u2 is upwards, so it has to be minus 37.8, and when we do that, we get T2 is equal to 37.8 divided by 9.8, and this comes out to be 3.85714, right? We have taken only 4 digits we are going to take, so we will take it as 3.8571 as the times seconds. So what's going to happen here? After it has dropped down, T2, when the velocity goes to 0, right? So when it goes to the top over here, second one, okay, it will not reach the top height because it does not have that velocity. So here, the time when it goes to the top would be, from here to here it is 3.871. So from this point I have to add 3.8571. So my T here, this point would be T is equal to T1 plus T2 over here. That would be 4.2857 plus 3.8571, and that comes out to be 8.1428 and then 28. Okay, so this particular thing here comes out to be here 8.1428, right? And how does it reduce? It reduces linearly. So this is how it comes down here. And then again, after it goes up, it has to come down, is it not? So whatever it goes up, once it is at the top, it does not lose any velocity. It comes down with the same speed. So it's going to take the same time. So from here, it will take the same time to reach back. I hope you are understanding. So it will take the same time to reach back, and this will be almost 8. So here, so this is the point here. I will rub this off. Okay, and let me continue this here. Okay, so it will reach over here, right? So afterwards also, when it reaches the top, and then it has to come down. It takes the same time. What is the time? 3.8571 seconds it takes. So the last t over here, last t, okay. So now when the ball reaches the ground again, when the ball reaches the ground again, time would be t1 plus t2 plus t3, right? What is t1? 4.2857 plus 3.8571 would be the second one, plus you have another 3.8571, which would be almost equal to 12 seconds. So in 12 seconds, okay, in 12 seconds, what will happen? The ball will go up like this, it will come down, then it will go down like this linearly, and it will go up like this. This would be the velocity versus time graph. I hope you have understood. Now further question would be, see, always when we solve some questions, we should see what other type of questions can be asked here. So one of the type of questions which can be asked with respect to this is, for the same problem, can we get velocity versus distance, that is space, or velocity versus displacement curve? Get it out, students. Can we find out velocity versus displacement curve? I'll give you some hints. We have to use v square is equal to u square plus 2as. This would be the governing equation. So velocity versus this would be root of u square plus 2as. So what will happen? The velocity will have a functional relationship of constant into root of this. Right? So it will be a root curve. So root curve is something like this, right? This is the root curve. Okay. So how you are doing it, I'm not saying this is the right answer, but you have to think a bit on this and try to find out what is the right answer for the same problem. For the same problem, what is the, instead of having speed time, can I get speed versus distance curve? Okay, so this is homework for you. I hope you will put your mind on this, and if you have any doubts, you can put it into the comment section, and I'll be very happy to help you out. So happy learning, students. Have a nice day. Thank you.